Hi guys, welcome back to another live stream. So I'm just going to confirm that the live stream is started because sometimes I've started the live stream and it's not yet even gone through. So I'm going to confirm this. But anyway, today we are going to be doing some chemistry past papers, and specifically we're going to be doing paper two, which is the MCQ questions. Yeah, so we're live. Yeah, we are live. Okay, so let's begin. Now I haven't looked at the paper, so everything you see right now I have not had a look at it before. So I think you'll see my thinking process towards each question, and hopefully I'll explain also which question is what, so you can also understand much better. So hopefully everything is good, the quality good of the live stream. Now I've started using my face cam in these videos, so hopefully they're much better. So hopefully we can connect better. Anyway, so let's begin. So we're going to start with 2021 Feb March, which is the latest one I could find online. I couldn't find the May June one or the May June papers because they just did it. It's actually yet June, so they don't Cambridge don't send them out. But if they come, I will sort of also do that soon. Okay, so we're going to start and just begin with the stuff. Okay, so let's begin. It says which row about a change of state is correct. So change of state, this is the first chapter. I've made a video on this also, so you can have a look at that from my channel. You can just find these videos. Okay, so this one it says okay, let's see, solid to liquid. Solid to liquid is when you have a solid, it's moving on to a liquid form. This is melting, so this can be correct. So the first thing is process. Process, everyone should get it correct. So you should know the process. When you get a solid to a liquid, we know it's melting. We're gonna do this energy change lost. So we're gonna do that, but later. Gas to liquid. Gas to liquid is not evaporation actually. It's the opposite. Liquid to gas would be evaporation. So this one's already out. Solid to gas. Solid to gas. Yes, this could be sublimation. Liquid to solid cannot be condensation. Okay. So that is that. It's gas to liquid, which is condensation. Okay. So we have now got two options. We have got either A and we've got either C. Okay, and we have to pick from those two. Okay, so now we have a look at the energy change column. So solid to liquid. Okay, initially solid to liquid heat is not given out. Heat is given in. For example, I have maybe a sugar cube and I want it to become a liquid. Or a better example, an ice cube, and I want it to become a liquid. Now, heat given out is exothermic, okay? But in this one, we need the solid to take in heat for it, to become a liquid. So that one can't be a possibility. But for C, heat taken in, okay, the solid will take in heat and therefore will produce the gas. So therefore, the answer for this question would be C. So the answer is C. So we'll do many of these MCQ questions just like this, okay? We'll do these types of MCQ questions more and more so you can, get a better gist of it. Understand how the chemistry MCQ questions are set, because most of these MCQ questions are like, repeated. They have a sort of structure. Okay, it says gases are separated from a liquid air by fractional distillation. It says the boiling points for the four gases are shown. Now, if it is monatomic and negative 200 degrees, so for this question, what you need to know is that to find the boiling point, because remember this one, it's a gas. Which gas? Liquid at negative 200. Okay, negative 200, it becomes a liquid, or what one will become a liquid. Okay, that means that boiling point simply means that it will, for example, water has a boiling point of 100 degrees, right? Sorry, 0 degrees. Okay, it's a melting point of 100 degrees, sorry. Or am I getting that wrong? Okay, wait, 1 second. I'm gonna search this on Google. Melting point of water. This is embarrassing. It's okay, it's 0 degrees. Okay, so boiling point is 100 degrees. Okay, this is embarrassing. Okay, but yeah, hopefully you understand that. Okay, so water's boiling point is 100 degrees, and after it boils, it becomes a gas, right? So if we use the same sort of scenario for that, for this question, you'll see that. Okay, so if it's negative 200 degrees, anything that's above this, okay, will not become a liquid. Okay, it'll remain as a gas. It'll remain as a gas. Okay, but then once when it's below it, we can, sort of assure this. So that therefore that breaks B down, breaks C down. So we can't have B or C. And then we can search what is a monatomic element. Okay, what is a monatomic element? Hopefully you can see this. So a monatomic element is simply, what are monatomic elements? Let's have a look at this. So monatomic or monatomic elements are elements that are stable as single atoms. Mono. Okay, therefore, which means, if you've noticed, it has, O2, for example. O2, if you've noticed, N2, N2. So all these nitrogen, oxygen, all those types, common ones, hydrogen, those ones are not monatomic. Those ones are, I believe, diatomic. Okay, because they have this number 2 in it. So this 2 right here. Let me show you. It has this 2. So therefore, nitrogen will move out, because remember, you can write nitrogen as N2, but argon you can't. So the answer would be A, argon. And yeah, that should be the correct answer. Now I'm using the marking theme, so I confirm my answers because I do not want to get the wrong information. So yeah, you can trust these answers that you see. Okay, number 3, it says that 2 different food colorings, X and Y, are tested using chromatography. And the pure dyes 1, 2, 3 are also tested. Chromatogram is shown. Okay, so it says which statements are correct. So okay, the first one is saying X and Y both contain 2 or more dyes. So we go to X and Y. X and Y, how many? They have 2 or more. Do they have 2 or more dyes? Let's have a see. Yep, it does have 2 or more dyes. Because look, X has 3. You can count these droplets: 1, 2, 3, and Y has 2. So it says 2 or more. Okay, so therefore this statement is correct. The next one says that dyes 2 and 3 are present in both X and Y. So we go to dyes 2 and 3. Are they both present in X and Y? Yep, they are. Right, one here, and there's one. 2 and 3, and there's one right here. Dyes 2 and 3 are both present in X and Y. They are both present in X and Y. 2 and 3. Yeah, they are both present in them. And then so even this one's correct. And then the RF value. The RF value is the distance it travels. The distance it travels. So what I can do is, remember, this one is 8. The 8. So I do RF value of die 1. So die 1 is right here. So what I do is I do 5 over 8. So whatever that gives you in your calculator will be hopefully 0.625. So I don't have a calculator right now, but yeah. Actually, I can get a calculator for you right now. Oops, sorry. That was computer science. If you are interested, you can have a look at that. Yeah, so if hopefully 5 over 8 is 0.625. So I think it is 0.625. It should be 0.625. So this should also be correct. So therefore the answer will be 1, 2, and 3. So the answer would be C. Number 4, which says which statement of the atoms of the all isotopes of carbon is correct. So this one is a question where you just need to know. There's no other way around it. You need to just know about the atoms of an isotope, or something like that. So here we're having a look at the isotopes of carbon. So indirectly, isotopes of carbon. Isotopes are simply same number of protons, different number of neutrons, right? So they have the same chemical properties. So therefore, what they're trying to say is that give the chemical properties of carbon. Okay, carbon chemical properties of carbon. Okay, so let's have a look at this. Carbon. Let's see. But in this, we are saying relationship into carbon, isotopes of carbon. Okay, so are they radioactive? No, they're not radioactive. They have not the same mass. Actually, they have different masses. Mass number is different. Do they have the same number of neutrons? No. So the last one should be D. It should be correct. They have the same number of electrons in the outer shell. Yeah, they do, because they have the same number of protons. Therefore, of course, protons equals to electrons. So therefore, it should be the same. Okay, silicon oxide. Okay, this is about structures. We've not done it in this channel, but yeah, so this is about structures, and this one you just need to know. But silicon oxide is like tetra, you know, so therefore this cancels, so it's these two, and it's more like close, so the answer should be D. I think so. Yeah, it should be D. Number 6, it says lithium and fluorine react with lithium fluoride. A student writes 3 statements about the reaction. Okay, so let's have a look at this. It says, okay, let's start. Lithium loses 1 atom when they react. Now remember, lithium, okay, lithium is a metal, right? Lithium is a metal. So for a metal to become an octate state is when the electrons are 8. To become an octate state, they have to lose 1. So when they react, they have to lose 1. So this first statement should be correct. Okay, fluorine is a nonmetal. Okay, fluorine is a nonmetal, and lithium is a metal. And we've learned about lithium actually. It's in group 1. So yeah, each fluoride ion has one more electron than the each fluoride ion has one more electron than the fluorine atom. Yeah, that's correct. That's correct. Each fluoride ion has one more electron than the fluorine atom. Yeah, that's correct. So fluorine is in group 7. Okay, so the fluoride ion will be in the octate state, so it will have 2 8 8. Okay, it'll be in the octate states. Okay, so what that means is that it'll have one extra electron, just one extra electron, so therefore that will be correct. Let's see the next one. Lithium fluoride is a mixture of elements. Mixture, no, it's not a mixture of elements, it's just 2 elements that are combining together. It's not a mixture of the 2, so the answer should be 1 and 2 only, I believe. Yeah, so it should be A, 6A. The next one, it says how many electrons are used to form covalent bonds in the molecule of methanol. So you're given CH3OH. It's saying how many electrons are used to form a covalent bonds. So in this question, I think you have to sort of structure it, maybe. But let's see. Let's see what Google says. How many electrons? Okay. How to find the number of electrons in a covalent bond. Sorry if it's making noise with my typing. Okay, the number of electrons required to obtain an octate determines the number of covalent bonds an atom can form. So I believe you can use your periodic table for this, and probably locate maybe. So let's see, we're gonna go to the periodic table and try to figure. There should be a periodic table actually. Yeah, there should be. So we'll have to locate carbon, right? So carbon, where's carbon? Carbon is in group 4. Okay, right here. Group 4. Group 1, 2, 3, 4. So it's group 4. Therefore, it will need how many electrons? So that means it's probably 2, 4. That's the electronic configuration. Sorry, 2, 2. 2, 2, yeah, it's the electronic configuration. So it'll need to lose 2. Yeah, it needs to lose 2. Because for lithium, it needs to lose 1. So this one should lose 2. Because the electronic configuration of lithium would be 2 1, right? Yeah, 2 1. So this one will have to so this one will be ending with 4, so you need to lose 4. Okay, so when we go back to the question, when we go back to the question, let's go back to the question. Again, this live stream is more figuring, so if you've wondered why, I'm sort of doing it, it's so that you can see, the way I approach the questions. Okay, so this one will need 4, so 4 plus hydrogen will need 1. But this, yeah, oxygen will need 2. Hydrogen will again need 1. How much is that? 4 plus 3. Oh wait, hydrogen should be, wait, so the equation will be 4 plus 3, okay, plus 3. Because carbon needs 4 to become an octate state. Hydrogen needs 1, but since it's H3, it'll need 3. Oxygen will need 2, and hydrogen will need 1, right? So I have combined it, but you can't separate it. And how much will this give? 7, 8, 9, 10. So this should be 10. So the answer should be D. So we've learned that to find how electrons are used to form covalent bonds, just look at how much they need to become an octate state. Either it's negative or positive, it doesn't matter how much it becomes an octate state. Okay, so that's a good question we got to know. Hopefully you also understood that. We move on to number 8. Number 8 says that manganese oxide has a high melting point and carbon dioxide has a low melting point. Which row identifies the attractive forces that are broken when these compounds are melted? So when these compounds are melted. Okay, so let's see. So it's saying magnesium. Why am I saying manganese? Magnesium, sorry. Magnesium oxide. Magnesium oxide has a high melting point. So initially when it is in high melting point, when just you see high melting point, that means that it should have a strong attraction, because it means that it'll need more heat to break down. Okay, therefore that's why it needs a high melting point. For carbon dioxide, it's a low melting point, so it should have a weak attraction between the molecules. Okay, because manganese oxide, we're having a look at the ions. Okay, and with carbon dioxide, we're having a look at molecules, H2, CO2, sorry. So the answer would be D. Yeah, should be D, because high melting point means strong, low melting point means weak. Okay, so temperature basically means that high temperature I need, it's harder to break down an ion or something like that. Okay, so hopefully you understand that again. Okay, so it's saying the ionic half equation of the formation of oxygen during the electrolysis of aluminium oxide is shown. So this is electrolysis. So it says, what are the values of X and Y? What are the values of X and Y? Okay, so now electrolysis, we haven't learned it yet. I haven't learned it. So I'm going to be skipping this because I don't want to mislead you. But if you have, I'll just tell you what the marking scheme says. The marking scheme says D. So I don't know how you come up to that, but it is to that. But I haven't learned it again. So yeah, hopefully you understand that though. But if you don't, I'll make a video on that soon. But it's not that I haven't learned it, so that's why I don't want to mislead you by just saying some random stuff and confuse you. Okay, it says the compound has a formula XF2 and a relative mass of 70. Okay, and then it says what is the element X? What is the element X? What is the element X? So it's a very easy question. First of all, you need to know what relative mass is. So RAM is simply the addition of this number. Let me show you in the periodic table. So it's the addition. For example, this one, what, Fe or F? It was F. Yeah, it's the addition of this bottom number, the proton number, 9. Okay, it's the addition of that, all of the additions of that. So it's 19 for this. Okay. So I'm gonna come back to the periodic table. Don't worry. Okay, don't worry. Okay, so it's F, right? So F is we just saw 19, so it's F2. So 19 plus 19. Okay. So let's make an equation. 19 plus 19 plus X should give you 70. Okay, because again, relative mass is the total of all. Yeah, it's the total of all. Now I'm going to open my calculator, so you guys also understand what I'm doing with the calculator, because sometimes people don't even understand to use the calculator. Okay, so I will add calculator. Right there, I've added my calculator. Okay, so what are we going to do in here is 19 plus 19 first. 19 plus 19 should give us 38. And then what I do is 70 minus, was it 38? Yeah, minus 38, which is 32. Okay, that means that I need to find some element that has the REM of 32. So we're going back to the periodic table and flip it. Okay, now we look at 32. We find 32 somewhere. So 32 should be somewhere right here, sulfur. Okay, so we see if sulfur is an option. Let's see if sulfur was an option. See if sulfur was an option. Was sulfur an option? Yes, it was. It was an option. So hopefully, yeah, that should be the answer. Let me see in the marking scheme. Yeah, that's the answer. Sulfur is the answer because it has relative mass of 32. So the answer is sulfur. Okay, it says the diagram shows a section of an overhead power cable. Okay, so it has an overhead power cable. So we have steel, aluminium, and ceramic, and it says which statement explains a particular substance is used. Why a particular substance is used. So why does the following used? Okay, so let's see what the this one is. So first of all, it says aluminium has a low density. Yes, it has a low density, and it's a good conductor. It's a metal, and most metals are good conductors. So the answer is A, even without looking at other stuff. Ceramic is not a good conductor, I believe. Conductor, sorry. Let's search though. Is ceramic a good conductor? Let's see. Sorry, I spelled that wrong, but is it good conductor? Okay, they are good conductors. Okay, so they are good conductors. Good to know. But it does not apply for this, I believe. Yeah. So let's see. Yeah. So it doesn't apply for this, as you guys can see right here. Ceramics are excellent conductors of electricity, but they don't apply, I believe, in this. Okay, during the electrolysis, okay, so we're not going to do electrolysis question, sorry about that. Okay, this says which row describes an endothermic reaction? Endothermic reaction will deal with reactions that take in heat, so which is this one. So the ones that take in heat would therefore be things that have low energy in the start and then gain energy as it goes. So this one can't be it. It can't be high. This one can be a possibility actually. B or D can be a possibility in terms of the diagram, but let's see this. Energy is transferred from the surroundings to the reaction. Ooh, yeah, that should be correct. No, this right here, from the reaction to the surroundings, is exotherm, it's releasing. So this one is from the surroundings to the reaction. Yes, the answer should be B. 14, it is about energies. Now, I haven't learned this again, so we're not going to do this. Hydrogen fuel cells can be used to power cars. Which statements about a fuel cell is not correct? So this is about fuel. Okay, so about fuel we have, let's see, a balanced equation of the reaction H2 plus O2. Is it balanced? Let's see. No, it's not balanced. As you guys can see, this one has 2 oxygen. This one only has 1 oxygen, so it's not balanced. The fuel cells generate electricity. They do. Fuel cell hydrogen is reduced. No, it's not reduced. It is, I believe, increased. I don't know though. This one I'm not sure, but I don't think it's correct. The reactants, the gases are room temperature. Yeah, that should be correct. So the answer is C. Sorry. So we move on. This one is the question on the rates of reaction. And it's saying that which equation represents a reaction where the rate can be measured using an apparatus. Okay, so this should be a redox reaction, I believe, a reversible reaction, sorry, because of the apparatus that I see. Okay, so we're looking at something that's most likely a reversible reaction, and the first one, I think, according to me, is correct. The first one should be correct. Hydrochloric acid plus sodium hydroxide is not reversible. Yeah, so the answer is A. And this one you just need to understand, experiments. That one would be the best one to do. 7, it says that P is a hydrated metal, salt with a blue color. When P is heated, water is given off, leaving a solid Q. So hydrated cobalt chloride. Which row gives the name of P and S? Okay, so the name of P first. Let's start with there. So because it's saying it's blue color, P is a blue color, it's either copper. Okay, so it's either one of these two, it's either copper. And the color of S, okay, it can't be this, it can be actually. So this one is the same, it doesn't change, I believe. So the answer should be C. It's copper and it should be blue. Okay, the last question now we're going to do, and just end the live stream after that. We did quite some questions. So this one is magnesium reacts with copper oxide to give magnesium oxide and copper. Which substance is the okay? So yeah, so magnesium reacts with copper oxide to give magnesium oxide and copper. Which substance is the oxidizing agent in this reaction? So this would be the oxidizing agent would be copper oxide, reducing the oxidizing agent in this reaction. This one will be then reduced, yeah, and give a copper. And if they asked you for the reducing agent, it would be magnesium oxide. Okay, so there you go. We are done with that, and yeah, hopefully you enjoy this quick live stream.